Hello, my name is Mr. Fontenot. Welcome to my YouTube page, Mr. Fontenot 1111. Please like, share, and subscribe. In this video, I'll be calculating the AC values from the Chapter 15 Math handout, problem number 18. Again, we have a random unknown combination circuit, and I'm given my V3 voltage amount, and I'm given all of my resistance amounts. So the first step I'm going to take is going to be to find RT. So I see that I have R2 and R3 that are in parallel with one another. So I'm going to combine those two values using the reciprocal formula. And I'm going to just bring value of R1 over and the value of R4 over. So this gives me 200 ohms in series with 222.22 ohms and 75 ohms. Again, the 222 ohms came from reciprocating resistors 2 and 3 through the reciprocal formula. Alright, now that I have these three in series, I can just add them together to get my total resistance, which is 497.22 ohms. I don't have my VT, so I can't go ahead and solve for any currents or anything, but I do have my V3 amount. I could solve for I3 using Ohm's law. I3 would be equal to this V3 of 15 volts divided by 500 ohms, which would give me 30 milliamps. But there I pretty much would be stuck, unless I understand that the amount of voltage that is across R3, the V3 value, is going to be the same as V2. Because V2 and V3 are in parallel with one another. And since I understand that V2 and V3 are in parallel with one another and I have the V3 value, I already know the V2 value. Now I can use Ohm's law to find I2, which will be equal to V2 divided by R2. 15 volts divided by the 400 ohms, giving me 37.5 milliamps for I2. And I understand that flowing through resistor number 2, I have 37.5 milliamps of current through this resistor. Through this resistor, R3, I have 30 milliamps of current. 30 milliamps of current. Well, both of those current amounts are going to come back together right here, and the sum of both of those currents must go through R1 to get back to the voltage source. So that tells me that I1 would be equal to the sum of I2 and I3. Same thing for I4. R4 is on the main branch, so this tells me that the current of I4, which corresponds to the current flowing through R4, is also going to be 67.5 milliamps. And it also tells me the total current amount, because whatever the total current amount is equal to whatever the main branch current is. Alright, now I can use Ohm's law to find for VT, IT times RT. For V1, I1 times R1. And for V4, I4 times R4. Now I just have to find any AC values I was asking for. So I've found all my RMS values here. Through all of those steps. Now I'll just apply whatever formula is appropriate to find the answer looked for up here. So IT peak is equal to the IT of 67.5 milliamps times 1.414. This will give me my IT peak value of 95.45 milliamps. V1 peak to peak, well, I have my V1 RMS value here of 13.5. If I multiply it times 1.414, that will give me my V1 peak. And if I multiply that number times 2, that will give me my V1 peak to peak, 38.18 volts. VTRMS, well, all of these values down here are RMS values, so the VTRMS is just equal to the 33.56 volts total RMS given here. Combination circuit with a random unknown. The key to solving this equation, this circuit, is to understand that whenever you are given the value of V3, you know that V2 is going to be that same number because V2 and V3 are in parallel with each other.